Were thermophiles the first life on Earth? And how hot is too hot? This is another video of my Basics of Life series. The overview. First, we're looking at the 60 degrees limit. That's not something God-given, of course, but we will talk about this. The 60 degrees limit means when you look at the yeast, normally above 60 degrees they stop working because they're dead, basically. And then we'll talk about the three domains and the history of life on Earth. And as a summary, we'll discuss models for early life in general. The 60 degrees limit, as I already told you, is given by some biological facts. For example, proteins start degenerating at a certain temperature. And we tried that out yesterday with Meta. Meta took the pictures on the right side and I took the picture on the left side with a thermal camera. So we tried out at which temperature the egg white starts degenerating. And you can see where it starts. Here there are two spots, a large spot and a smaller spot. And this is the thermal picture. You can see these two bubbles are actually here. And this is also the bubble here. So you can more or less directly tell that at 54 degrees the egg started degenerating. And the frying pan was a bit hotter than that, 64 degrees. Yes, if you compare this to the maximal temperature on Earth, I always thought it would be something like 57 degrees measured on the ground. But if you measure it by satellite, there were instances of 80.8 degrees on the ground on Earth. And the hottest place normally tend to be 20 degrees north and south, but it can go up to 40 degrees. For example, some places in China also tend to be very hot. And yes, if you put some proteins on the ground, they will degenerate then at this temperature. Here the trees of the three phyla with the archeae, the eukaryotes and the bacteria. The big question is which one came first. And you can look up these trees in the internet and you will find that each one looks different. Some have this LUCA thing in the beginning, which is a common ancestor. But how did it look like? And some people say LUCA didn't exist at all. And in all of these three branches of the tree, you find extremophiles and thermophiles, which is interesting. At first sight, it looks very logical because the Earth was hot in the beginning. So life that was adapted to high temperature had an advantage. And again, the problem with these trees is, contrary to higher life, in bacteria you have horizontal transfer of genes, which makes it very hard to disentangle these trees. Here I made a plot of animals where they live in terms of temperature and also where they live in terms of acidity. For trees we know that some like acid ground, some like, and of course trees can't choose. They are where they are. but some thrive and some don't. And there are always some extreme little animals that survive very deep underground, or even in a battery with the acid, this kind of thing. And this again is an attempt to give order by clustering. This very typical case of a cluster analysis, just they made it round. Although here there's a break, so it's not really a ring, it's just something linear that they turned, squashed into a circle. And these are bacteria. As we know, most are helpful and some are deadly. So, as an overview of extremophiles, of course, depending where they live, there are the Arctic ones in the cold marine sediment. There are the ones that live in cold seawater. There are the ones that live in cool soils. The ones that live in permafrost. And the ones in the laboratory. And then there are the ones that may live in extraterrestrial environments. Although so far we don't know any bacteria that away from Earth. For once there was this tale about the moon. NASA brought back probes and that have been contaminated 3 years earlier. So people thought some bacteria survived on the moon for 3 years, but later it turned out to be a measurement error. So the Earth is so far the only place where we have found life, even for extremophiles. This again is one of these, a form of putting bacteria and their similarities. And here there are the archeae that are thermophiles. But again, there are also bacteria that are thermophiles. And here also, so at very different parts of the trees. And here again, there's this attempt to order them depending on where they live. For example, here you have a volcano. And some live at considerable depths below the surface. Some live in the ice, some live where it's hot, and some live close to nuclear reactors. I mean, if people want to investigate this, they can travel to Pripyat in Ukraine, where this reactor has burned. People say blown up, of course, but it has blown up first and then burned conventionally. And the material was spread over the whole of Europe. This was in the 80s, I think. I was still a child then. And around there you may find some bacteria that are strange for sure. Simpler forms that's something that is always discussed in the life and space literature, that the simpler forms of life have a wider set of environments where they can survive than complex forms. Most are archaea or bacteria, but some are also eukaryotes. And they could be used as models for extraterrestrial life. And here there's a temperature scale again. 20 degrees, 50 degrees, 300 degrees. like the sulfur-dependent archeae. Some of them may have survived for almost the whole time where the Earth was there. But the question at the beginning of the video is, were they the first? Yeah. But the literature says that mesophiles are more likely to be among the first in thermophiles. They see this in genetic studies because they can more or less tell which genes have been there from the start and which genes mutated later. And there are some hints that thermophiles came only as an adaptation of heat out of the mesophiles. So this is the small contribution to the large debate for life-producing environments. Cradle of life. Was the cradle of life lukewarm ponds or hot vents or clay minerals? I talked about clay minerals in a recent video. Sulfide minerals or water droplets. And this would be the hot vent thing because thermophiles would be found there. So they are just one of several possibilities. An argument for thermophile is that they managed to produce some early adaptations that have been used far more widely later. For example, pigments for radiation protection and thick polysaccharide sheets to maintain the humidity. Again, that's the same as now with the global warming crisis that we have. The big problem is less the heat than the dryness, actually. And this is the same for microorganisms. Once they're dry, they will die very quickly. So they have to find ways to keep the water together. And these are two examples. And these two examples of thermophiles come from very different branches. These are bacteria and these are eukaryota coming from the fungi. So to conclude, of course we don't know, but it has some likeliness that thermophiles were the first, but there are many other possibilities and we can't really answer the question. Basically also because these were all soft animals, and from soft animals you don't find many remains later. That's the problem. But I'll keep you posted in case I find out more over time. So keep looking up and stay curious, and thanks for the attention.